Alright, geometry students, I've done a little bit of research on how to fix the audio on these things, and I think this should be a little bit better. Okay, so here we are in geometry section 9.3 and 9.4 about arcs. And 9.3 is about arcs and the angles involved with them, and 9.4 is about arcs with the chords associated with them. So this is nice. These two are pretty closely related. So first of all, what is an arc? An arc is this part of a circle. You just have any little circle and you have 2 points on it. The arc is defined as this little strip of circle here. And this isn't Sketchpad, so I can kind of do whatever I want here. An arc is any length of circle. It can go beyond halfway there. You can have an arc that's that big, or you can have an arc that's very, very small. They can be almost straight lines if the circle's very big or if the arc's really short. And that kind of thing. If the arc is, well, let's talk about how you measure an arc first. First of all, to measure an arc, in Sketchpad I actually have to click on it. Go to the measure menu, which you can't see. Anyway, arc angle is what we're talking about for arc measure in our book. Arc measure is really the amount of degrees really around this curve. If you think about the whole circle is 360 degrees, if I do that, you get really close to 360 degrees. That is basically describing how big this arc is. And if I change the size of the circle, it may change. Oh, great, I can't really change it. There's a much bigger circle. There's a really small circle. How can I get this smaller? I've hidden the point that changes actually the size of the circle. So, oh, there we go. Notice this is a 52-degree arc, and that's a 52-degree arc. They seem like they're different sizes, but actually, if I'm talking about the degree measure of the arc, that's as much circle as that is. Or if I make this like say around a half a circle, that's a half a circle, and so is that. It just happens that the circle's smaller. Arc measure is defined in degrees, not in length. That's called arc length, and that's something else, and we will get to that later. But oh, that's all. Look at that. That's about 90. So quarter circle. It curves as much as a bigger one because it goes that much around the circle. Where do I find this degree on my protractor? Well, it turns out you can find this degree if you're talking about measuring this angle right here. Measuring that angle that's formed at the center of the circle is, guess what, the same as this. I can measure this angle, and lo and behold, that's exactly the same thing. So here's a 113 degree angle, then that means we call this a 113 degree arc. Okay, pretty straightforward. It gets a little tricky when we start talking about arcs that go back here like this. Now here, Sketchpad's going to measure this arc, this angle, and tell me it's 130 degrees. However, the arc, I've got more than half a circle here. I've got more than 180 degrees in this bolded part down here. This arc is actually 229 degrees of the circle. Sketchpad treats its arcs and its angles sort of differently. Anyway, but you could probably imagine then that if this arc is 239 degrees, this arc should probably be 121 degrees, meaning that the measure of this arc plus the measure of this, sort of this dotted arc that's left plus this bold arc that's already here, that ought to speak to the whole circle. So that's 360. Anyway, yeah, our book talks about this too. You can have arcs that are bigger than 180. This type of arc, when it's bigger than 180, is called a major arc. And this little arc in here with the dotted line, this is called a minor arc. So minor arcs are defined to be arcs that are less than 180, whereas major arcs are defined to be arcs that are greater than 180. Whenever you put 2 points on a circle, I've got a point there and I've got a point here. I've kind of cut the circle. Whoops, I don't want another point. Whoa, I really don't want that. I've kind of cut the circle into 2 arcs here. There's an arc on this side, and there's this huge arc on this side. This one's called the minor arc, and this one's called the major arc. If you're going to name a major arc, you need to, whoops, I keep doing that. You need to, again. Okay, you need to name it by 3 points. Here we go. Point D, point E, point F. If I am actually going to, why does that keep happening? If I'm going to talk about this little arc in here, I would call this arc DE. If I wanted to talk about this major arc all the way around here, oh, and can I write on this fairly easily? Oh, I think I can. This little arc from here to here, that I would just call arc DE. And I can put a little thing on like that. And that is what I mean when I'm saying this one here. This big arc around here in our book, the major arc, I would have to label. They set it up so you have to label with 3 letters. D, because I would just say DE, we want that to not be ambiguous. We want that to be just one thing and not have everybody go, oh wait, do you mean this one or this one if you say DE? Because it could start at D and go to E, or it could start at D and go that way to E. So the convention here is if you want the major one, then you are in the business of having to use 3 letters to mark D to F to E, and that's what I mean by major arc. Sketchpad doesn't need that because Sketchpad is so snazzy. All it needs to do is highlight the one it's talking about. So when it says here, when it says measure of arc AB is 222, it really means this major one, and there's no point out here. So it's a tiny thing that's different with Sketchpad. Anyway, minor arc is, if you just say arc A to B, you mean the minor arc. If you want to talk about a major arc, which really, truthfully, doesn't happen that often, you should label 3 points. So I should put another point in here and say, okay, I really mean arc AGB for this great big one. All right, so there's what arc measure is about. Here I go through that whole thing about major versus minor and the notation and all that kind of stuff. Next thing, semicircle. If it does happen to be exactly 180 degrees, and I had that happen a little bit on the Sketchpad document, if it turns out to be exactly 180, you still don't need 3 points. 2 points is good enough. If it's exactly 180, you just say that's a semicircle. I'm sorry, you do need 3 points. You need 3 points because we don't know which one you're talking about. Are you talking about sort of the one on the left or the one on the right? If this was exactly 180 degrees, I'd have to specify. Can I get that to be 180? Probably exactly. No, probably not. Really close. I would have to say, if I'm saying, which arc am I talking about? If I'm talking about this one, I'd have to say AGB. If I'm talking about another one over here, I would have to say, well, I mean that one up there, and I'd have to call that one something like AHB. And that's different. I could call it BHA or AHB, and this one I could call AGB or BGA. It's the same thing. But yeah, with a semicircle, you do have to say 3. I just realized something for my document today. I don't actually have any video questions in here. That's kind of a anomaly, but as I paused just there and I went back, I looked at this thing and I'm thinking, what on earth would I even ask you in a video question here? All this stuff is simply identification of things and some first basic theorems. It's really hard to even apply anything here. We'll get to it in class. So you're kind of off the hook today in that I'm not going to ask you any video questions. That won't happen very often. Okay, so back to arc measure and that kind of stuff. Setting up arc measure and this whole idea of this whole system of how to measure and label arcs and stuff sets up a whole new system that's as rich and as full and as, much to deal with as when we were talking about measuring angles or measuring segments. And then so we have to set up things like, well, when is it okay to add them? Well, just like segments, it's okay to add them when when 2 of them are kind of attached to the common point. I can add EB and BC here, and Sketchpad lets me do that. Also, if I wanted to add that little arc, and can I make an arc to point H here? It's kind of tricky to get Sketchpad to construct the arcs in the right part of the circle. If I construct an arc, see, like right there, it constructed it not really in the place I wanted it, but that's okay. I've already measured arc AB. Let me hide these here. Arc AB, I've got measured. That's the, whoops, I'm accidentally right-clicking. This is the measure of arc AB in terms of degrees. I could measure mark AH in terms of degrees. Oh no, I can't. Where's AH? Okay, there's AB. I just constructed one. Is it from B to H? Oh, I think it's from B to H. Interesting. All right, I'll have to fix this and get back to you. But you notice how in the order in which I click stuff, I can't get these arcs to unattach, I don't think. All right, be right back. Well, the good news for you is you're not going to have to construct arcs very much in Sketchpad. Anyway, I made a new one here, arc IA, and you see when I select that one now, it's just selecting that part there. If I go to measure that arc, notice it's going to be like 38 degrees, and that's just going to change I to A. This is B to A, and guess what? Ooh, exactly 40. If I really wanted to know from I to B, I could just add that one plus this one, and I would get exactly, 91.07, and that's appropriate to do that. If A moves around, that's not going to change the total. It's exactly like segments, so I don't think that's any big surprise. All right, the next one, why is that little thing in my way, is the arc congruence theorem. 2 arcs would be congruent. It's following me around. Oh, come on. Can I get that to move? I can't. Arc congruence theorem is when are arcs congruent? Arcs would be congruent, guess what, if they have the same arc measure. What is this thing doing here? Anybody have any ideas? Let me know how to... Oh, I did it. Okay. If this arc is 72 degrees and this arc is 72 degrees, guess what? We'll call them congruent. It's kind of like with segments. I'm sure you're not really surprised by that. Arc chord theorem. All right, you say an arc. Remember we talked about chords in the last section. What is the chord of an arc? Let's go ahead and go back here. The chord of an arc basically just means the segment that attaches the 2 endpoints of the chord. So that's the chord of that arc. and that's the chord of that arc. And as the chord gets bigger, so does the arc. And if the chord is a diameter, then the arc is a semicircle and all that kind of stuff. Major arcs can have chords, just like minor arcs can have chords. The major arc and the minor arc would have the same chord, basically. Anyway, so here's some arcs with their chords in them. They're not always attached. I just had them attached in this document, as you see how I had to make it there. Anyway, if two chords have the same length, then we're on the same circle here, then guess what? The arcs are going to have the same measure, and the converse is true. If the arcs have the same measure, then the chords are going to have the same length. Now you're probably wondering, oh my gosh, am I going to have to name this in a proof or any of these other ones so far today? I don't think so. I think these are going to be the types of things where you're going to want to know how to do that, because you're going to have problems where you know this length, you know this length, and you might know this chord. You might know this arc measure, and you need to find this one. Or there'll be some overlapping stuff, and you want to use this property to calculate some things in a picture. And if I know you very well at all as a group, I think you're going to think that kind of reasoning is a lot more fun than the proofs we've done. Anyway, here I use this kind of prefix or sentence stem on all these. It says in circles of the same radius. Here I'm just marking the fact that we have one circle with both these things going on. We have a chord and a chord here that are congruent. Therefore, the arcs have the same measure, but you could also have two different circles that had the same radius, and if you had one of these in one circle and one of these in the other circle with the same radius, then those arcs will also be the same. I was just saving space here. And honestly, when you see these problems, it's more often than not in the same circle, but realize it's also true. If I had another circle over here with the same radius and same chord, then the arcs would be the same measure as these. Or if I knew that the arcs were the same measure, then I know the chords were congruent. Okay, that's why I think there's no big, huge surprises in here. There's actually not much left. I might finish this in one video segment. All right, chord bisector theorem is that if you have a diameter, I don't know why they say diameter, they don't say radius. There must be a reason why they want to say diameter. Anyway, it would also work for radius. If you have a diameter that pierces this chord at a perpendicular bisector, or sorry, at a perpendicular, it will turn out to be that it is the bisector. This is a lot of stuff here. It'll turn out that it is the bisector. You can imagine an isosceles triangle here with the two radii of the circle. That has to be isosceles, and if you hit that perpendicularly, it's going to have to cut that in half. And if you continue that, whoa, I'm moving it. And if you continue that, oh, there's my friend again. If you continue that, it's going to also bisect this arc. It's going to cut the arc in half. I don't think that's a great big surprise to anybody. Let's go back and talk about that in Sketchpad. If I construct a perpendicular here, that's going to cut this one in half. You can kind of forget about this one for a second. That's just kind of in the way. Hide that. Okay. This is going to be perpendicular here. I constructed it to be perpendicular. If it's perpendicular, notice how it's always going to cut this thing in half. It looks like it is. I'm just asking you to trust me here. It's going to cut this arc into two pieces. If I drop a point right there and a point right here, these two things, those 2 points I just put on there, I think I hit that second one right. Whoops. Those are always midpoints. This is a midpoint of that segment. This is a midpoint of that arc. If this is perpendicular. Oh, and I can mark. Check how snazzy this is. I can mark that perpendicular right like that. If that's perpendicular, then it cuts this perfectly in half, and it cuts this perfectly in half. Ooh, I can even do this and impress you with my Sketchpad skills. All right. So those will always be half and half if this is perpendicular. And the converse is also true. If I know this cuts this in half and it cuts this in half, then guess what? That guy is going to be perpendicular. And the very last one, I got a minute, is if two, can I scroll that up anywhere? I can't. I could do this and I could get more room. Great. If, okay, last question, last thing down here. If a circles of the same radius, or you have two chords that are congruent, they turn out to be the same distance from the center. Let's talk about that. If I look at the distance here from C to this point here, J, that is the distance really that this chord is from the center. The distance from this center point C, the center of the circle, to this chord is defined as this perpendicular distance. The farther away that moves, it sort of determines how big this arc is. If I have another arc that's the same length, that has the same perpendicular distance to this center, then guess what? If this perpendicular distance here is the same as this one here, they're sort of those chords are the same distance out away from the center. Then they would have to be the same length to fit into the same circle, which would mean that their arcs would have to be the same also. All right, thank you very much for watching. I will see you in class, and you can thank me for not making you do any questions this time.